Welcome back, friends, to our 70th episode. Today, we're tackling a big question. What's the real cost of making our systems resilient? We often hear terms like disaster recovery or multi-site active thrown around as the ultimate solution to keep things running, no matter what. And they work. They can withstand major disasters. But here's the catch. The costs can skyrocket. So let's dive into the true cost of resilience. First, let's get our key concepts straight. We'll be talking about reconciliation, disaster recovery, multi-site active, replicas, and failover. These might sound technical, but the core ideas are surprisingly intuitive. To make it easier, let us use a metaphor from the world of logistics. Imagine we rerunning a business that ships goods from warehouses. In this analogy, our data is the inventory. Our servers are the warehouses, and the record of all transactions is our ledger. Now think about disaster recovery. This is like having a primary warehouse and a separate backup warehouse in a different city. This backup warehouse is usually idle, just sitting there, fully stocked and ready to go. If a fire, a flood, or some other disaster hits our main warehouse, we can switch all our operations over to the backup. The goods are safe, and we can start shipping again. This is great for surviving a catastrophe, but you essentially paying rent and maintenance for a whole building that you not actively using most of the time. That's a significant cost. Now let's consider multi-site active. This is a different strategy. Instead of one main warehouse and one idle backup, we have multiple warehouses in different locations, and all of them are operating simultaneously. When an order comes in, it can be fulfilled by whichever warehouse is most convenient. If one warehouse goes offline, the others just pick up the slack. There's no downtime. Customers don't even notice a problem. This sounds even better, right? Continuous service. But now, instead of just paying for an idle backup, you're running multiple active sites. This means more staff, more operations, and more complexity to coordinate everything between them. So how do these warehouses stay in sync? This brings us to the concept of replication, specifically master-slave replication. Imagine our main warehouse. The master has the primary official ledger of all inventory and orders. The other warehouses, the slaves, don't write to their own ledgers directly. Instead, they constantly receive copies of the updates from the master's ledger. The master says, "We just received 100 widgets," and all the slaves update their books to match. This ensures that every location has the same up-to-date information. It's a one-way flow of information from the master to the slaves. But what happens if the master warehouse itself is the one that gets hit by a disaster? This is where failover comes in. A failover is the process of promoting one of the slave warehouses to become the new master. We essentially say, okay, the main office is gone. Warehouse B, you're in charge now. You have the most up-to-date copy of the ledger, so from now on, you'll be the one making the official record. The other warehouses then start listening to this new master. This switch allows the entire system to recover and continue functioning, even after losing its primary component. Now, let's connect this all back to our digital world. The warehouses are our data centers or server clusters. The ledgers are our databases. The process of keeping them in sync is data replication. Whether we're talking about disaster recovery or a multi-site active setup, the fundamental mechanism is the same. We create extra copies, or replicas, of our data and our systems. Here is the core insight. Disaster recovery and multi-site active are strategies that use extra replicas to buy recoverability and the ability to provide continuous service. You're trading money and resources for peace of mind and uptime. The cost doesn't just come from the extra servers themselves, which is like paying rent on more warehouses. It also comes from the network traffic needed to keep all these replicas synchronized. That's like the cost of constantly shipping ledger updates between your warehouses. And most importantly, it comes from the sheer complexity of managing this distributed system. Coordinating failovers, ensuring data consistency across multiple sites, and troubleshooting problems in a complex network is a huge operational challenge that requires specialized expertise and sophisticated tools. Think about it. In a simple setup, you have one system to manage. With a disaster recovery site, you now have two systems, and you need to ensure the backup is always ready. With a multi-site active architecture, you might have 3, 4, or even more active systems that all need to work together flawlessly. Each new replica multiplies not just the hardware cost, but also the management overhead. Your bills start to look scarier and scarier. The number of things that can go wrong increases, and diagnosing a problem becomes much harder. Is the issue with the application, the database, the network connection between Site A and Site B, the failover automation script? The complexity grows exponentially. So the true cost of resilience isn't just the price tag on the extra servers. It's the sum of the hardware, the network bandwidth for replication, the operational complexity, and the engineering effort required to build and maintain it all. It's a trade-off. You're paying a premium to protect against rare but catastrophic events. For many businesses, especially those where downtime means massive financial or reputational damage, this premium is absolutely worth it. But it's crucial to understand what you're paying for and why. You're not just buying hardware. You're buying an insurance policy written in code and infrastructure. As our systems get bigger and more distributed, with more and more warehouses and replicas talking to each other, understanding the costs becomes critical. It's like running a global logistics empire. The shipping bills can become overwhelming if you don't know how to read them. And that brings us to our next topic. With all these systems and warehouses communicating, the bills for data transfer are getting more and more complicated. It's time we learned how to read the freight cost model of the cloud. In our next episode, we'll break down how data transfer is built and how you can optimize it to keep your resilient architecture from breaking the bank. Thanks for watching today. I hope this gave you a clearer picture of what it really means to build resilient systems. If you found this helpful, be sure to like, subscribe, and hit that notification bell so you don't miss our next deep dive into cloud costs. See you in the next one.